So here's a little extra help with 4.4. Now with logarithms, there's many ways that you can do things. So you may see it a little bit different in a problem. I just want to show you one way as we kind of work through some of these problems. So let's start with number 1. When in doubt, if it's in a form that you do not understand, do your Snell method. And so I'm going to convert this from an exponential back to a log, and this would give me log base 5 of 20 equal to x. I wasn't getting anywhere working with the 5 to the x power, because 5 to the first is 5 to the second is 25, and it jumps right over that 20. But since I can jump to this, now that I have everything equal to x, in order to execute this and get the decimal number, I can then do my change of base formula, and I could say, let's do ln of 20 divided by ln of 5, and that would be equal to x. And then I could plug that in my calculator. So let me jump over to my calculator. And so this is the same calculator you have in your line homework. And so let me go ahead and clear this out. So I'm going to do ln of 20 divided by ln of 5. And once I have all that punched in, I can hit enter. You can see I have my answer here of 1.861353116. So let me jump back over here and write 1.8613, especially if it told me to round to 4 decimal places. So that's one way to approach that one. Now in the next one, it's real similar because it has 7 raised to something with an x and an equal to 44, but I'll work it a different way to show you how this is going to work out. So my problem is I have an x up here in the exponent. And so I'm going to use my log properties, because we had one that if we had, say, ln of a to the x, that if you are working with the log, that this exponent can come out front. So I'm going to do that here with number 2. I'm going to log both sides so I can create this situation and then apply that property. And so if I ln both sides, it gives me ln of 7 to the 3x minus 2 equal to ln of 44. And then I'm going to pull this exponent out front. So it gives me 3x minus 2 ln 7 equal to ln of 44. And then I'm going to solve for that x. So I'm going to divide both sides by ln 7. And so that gives me 3x minus 2 equal to whatever that number is, ln of 44 over ln of 7. And then I'm going to add 2 to both sides. And then I'm going to divide by 3. And so x would be equal to ln of 44 over ln 7. Once I get this number, I'm going to add 2 to it and divide all that by 3. So again, we need to jump over to our calculator and execute that. So I'm just going to start typing here. So I'm going to say ln of 44. You always want to put whatever you're logging in parentheses, divided by ln of 7. Now I try not to type everything in at once, so I'm going to go ahead and hit enter on that. And then I'm going to use this button here, A and S. I'm going to take the answer and I'm going to add 2 to it, enter. Then I'm going to take that answer and divide it by 3. So that kind of saves me from typing in everything at once. You can, but I feel like errors can happen when you're trying to figure that out. But let me show you that here. So we get 1.3149. So I could do, let me jump down. So I could do ln of 44 divided by ln of 7. And out here side, I want to say plus 2 on that. And then I'm going to divide that whole thing by 3. And you can see, again, similar values, but it can get a little complicated when you type it all in. So we have over here, x equals 1.3149, rounding to 4 decimal places. So I hope that helps with what we have going on with 1 and 2. You can always practice those and then do similar exercise to try a different one and see if it works out as well. But again, you're going to have to use your online calculator or your handheld scientific calculator to help you with that. So let's look at number 3. Looking at number 3, I see that my whole goal is I want to get this x by itself. So with this one, I'm going to reverse it. I am going to do the Snell method, change this back to an exponential. So I start with my 2, loop to 3, and then end on this grouping. So it gives me 2 cubed equal to 4x plus 5. And so then I'm going to start working with that. Well, 2 cubed is 8 equal to 4x plus 5. I'm going to subtract 5 from both sides. That gives me 3 equal to 4x. Divide both sides by 4. And so then x is equal to 3/4 or 0.75. And so you can see the main step was right here in converting it to that Snell method. Now when I do it again with number 4, it looks a little bit different. So I see it written as a log. I'm needing to get this x by itself. So try something. And so I'm going to try that Snell method. So I'm going to start with 4 and I'm going to loop around. So it gives me 4 cubed equal to x to the 9th. And then to get that x by itself, I would want to 9th root and get that x alone. Now that does look a little bit hairier than the last one, but again, excuse me, again, let's go to that online calculator and get a better value for it. And I'm just going to plug that into that calculator over there. Okay, so let's go ahead and clear this out. So you can see this has the square root. So if I type it, I could do like square root of 4. That gives me 2. But this one has an n right here. And so I'm going to hit 9 first. Then I'm going to hit that nth root. Oh, excuse me, I was trying to work it like my scientific calculator. So I'm going to hit the nth root. And then right here in this box, I'm going to put that 9. And then right here in this one, I'm going to do 4. And I want to raise this one. So I do shift and number 6. Raised to the 3rd power. I'm going to hit enter. And so you can see, as hairy as that looks, we do get a value of 1.5874. So this is equal to 1.5874. And then the key is that in any of these, you're showing all your steps along the way. So if something happens or a calculator issue happens, you can get partial credit as you go. So I hope that helps with numbers 1 through 4. So now let's look at 5 through 8 here. Same section, 4.4. So with this, we have a little bit more legwork. We're going to use some of the same techniques from 1 through 4. So we might have to use our Snell method, or we might have to use some of our logarithm properties. The first thing I want to do is I want to get this log to look a little bit better. And again, there's a couple different ways that we can do this. This is just my approach to start here. And so what I want to do is I want to first get rid of this multiplication by 9/5. And so I am going to divide both sides by 9/5. And so that would cancel with this one. And that would give me log of 5x is equal to, okay, so this is going to be 2 divided by 9/5. In order to divide with fractions, you want to keep the first one, change it to multiplication, and flip the second. So this gives me log base 5 of x equal to this over here. So we're going to make that a fraction, multiply across the top to give me 10, okay, across the bottom to give me 9, or again, we could switch over to that calculator. So I have log base 5 of x equal to 10 over 9. Now we're back to 1 through 4. I'm going to Snell it around. And that would give me 5 to the 10 over 9 equal to x. And I'm going to switch over to my calculator. And so I'm going to say 5. And on my keyboard, I'm going to hit Shift 6, which throws it up into that exponent, or I could use this button here. I'm going to use parentheses. I'm going to say 10 divided by 9. You can see that's all up in my exponent. And then I'm going to hit enter. And that gives me 5.9790. So best answer would be 5.9790. And that would be it for number 5. Let's look at number 6. Now 6, 7, and 8 are all real similar because you can see that they have 2 logs on the left and a numeric value on the right. So what we need to remember for these is we need to remember our log properties. Remember that if you have log of A times B, that could be expanded to log of A plus log of B, or back and forth. And then if you had log of A over B, that would be log of A minus log of B, using those properties. So I'm going to use those here. I'm going to use that top one, and I'm going to go this direction. So I'm going to condense it. And so this would be log of x times x plus 3 equal to 9. And then I'm back to what we were doing in 3, 4, and 5. This, when it doesn't have a base, is a base 10. So I'm going to snell it around. So it gives me 10 to the 9th equal to x times x plus 3. And then I'm just going to solve my quadratic. So I have 10 to the 9th equal to distribute. So I get x squared plus 3x. And I'm going to subtract that over. So I get 0 equal to x squared plus 3x plus 10 to the 9th. Now, sadly, you do have to use quadratic formula on this. So you're going to have to say negative b plus or minus the square root of, let's see, b squared minus 4ac. And I'm just leaving that 10 to the 9th because I don't want to write out a bunch of zeros. That's like a million or something. Divided by all over 2a, so 2 times 1. Now, I do want to show you that you can type that in that scientific calculator over here. So let's switch over to the calculator. So let's jump on here. And so this would be negative 3. And I'm going to do plus the square root of, let's see, it was b squared. So 3 squared, which is 9. But if you like, you can type in 3 squared minus 4 times a times c, which was raised to the 9th power. Now, I want all of that divided by 2a. And so you can see that one doesn't look like it's going to work out. It's just undefined. But if I take this same one and now I hit subtract on it, hit enter. I apologize for that. That gives me undefined. And if you look back at what we were just working on, right here, when I took this 10 to the 9th power and moved it over here, I should have subtracted it. And so that would actually give me a negative right here, which is great because that's going to make our life a lot better now. It's staying undefined because we had minus a large number and we can't have a negative under square root in the real numbers. So I'm going to switch over here. And the good thing about this calculator is I can just come right here and put in a negative. And you can see that's going to work out for us. So we have about 31,000. And then again, we can click here, erase, and put our plus sign. And this one gives us positive 31,000. And so using the calculator is really nice because, again, you can switch between symbols really easily without having to enter anything in. And so I believe on this problem it said to use the larger value. And so this would be our answer right here. So let's go ahead and switch over. And so for this answer, x would be equal to 31,621.27664. So it does get a little hairy down here working with those larger numbers, but it's really combining together because we've been solving for x and solving quadratics since Unit 1. So I hope that helps with that. Let's look at 7 and 8. With 7 and 8, you're going to be doing condensing. We're going to snell it. We're going to solve it. So I'm going to use the second property right here. I'm going to work it backwards. And so I'm going to say, let's condense this down and get rid of the subtraction. So that would be log of x plus 5 over x plus 1 equal to 2. Now we have it condensed down to log of something equal to a number here. I'm going to snell around. And this is, again, base 10. So it gives me 10 squared equal to x plus 5 over x plus 1. Now I am going to get rid of this division, so I'm going to multiply both sides times x plus 1. Sorry about my pen there. So that gives me x plus 1 times 10 squared equal to x plus 5. 10 squared is 100. And then I'm going to distribute that. So I have 100x plus 100 equal to x plus 5. And then I can just solve for x. So minus x, that gives me 99x minus this 100. equal to negative 95 and divide by 99. And so this answer would be negative 95 over 99. As weird as some of these answers are, just stay with it. It's okay. Not everything's going to be perfectly ones and twos. Okay, let's work this next one. So we got a minus sign right here, so we can condense it. That would be log base 4 of x squared over x plus 4 equal to 9. And then snell it around. So 4 to the 9th equal to x squared over x plus 4. I'm going to work it just like I did number 7. So I'm going to multiply by x plus 4. Write a little bit clearer for you there. And so that gives me 4 to the 9th x plus 4 times 4 to the 9th. I'm going to have to switch over to that calculator. Equal to x squared. And we're going to have to get this all over to one side and solve our quadratic. So this is going to be equal to x squared. I'm going to figure out this number and then I'm going to move it over there. So I'm going to say minus. So let's see. 4 to the 9th. Which is 262,144x. So let's use that calculator on the other screen. And then I also want to pull this one and pull it over there. And let's see, that would be 4 to the 10th. And so it's going to be 0 here, nothing's left. And it's going to be minus 4 to the 10th, which is 104,8576. Whew. These numbers are all not being very nice right now. So let's work through that. I jumped it over here to a new page because I want you to kind of see what's working out here. It really would probably be best for us if we used these numbers as scientific as this exponent notation. That's one of the reasons we like exponent notation, because of the fact of instead of working with these super large numbers. And then we can, so I'm just going to change it back to 4 to the 9th and 4 to the 10th. And so I'm going to say negative b, this is my a, b, and c value, plus or minus the square root of b squared minus 4a, and then c, lots of 4's today, all over to a. And we're just going to switch over to our online calculator to help us with that. So we're going to have negative b, which was negative 4 to the 9th. And we're going to do plus first, and then we'll just switch it back to minus. The square root of b squared. So that was negative 4 raised to the 9th. Close it out and square it. So b squared minus 4 times 1 times c, which was 4 to the 10th. And then I'm going to highlight all of that. I'm going to hit my division sign, divide it by 2 times a, so divide by 2. And so we've got this really large number. And then I am just going to copy and paste that here because I want to see both numbers together. And I'm going to do minus. And so that gives me my two values, which I'm probably going to use that 4 to help me with that. Lots of 4's today. And so let's go ahead and switch back over. And so that gives me 4 x equal to 4. And if we do 4 decimal places, we get this. And then that other one was 262139. Point, I think it had a bunch of 9s in there. Yeah, they have 4 9s. And so then that would be your two values. And I think it said only to enter one. So I would probably just enter this one. So definitely a lot more complicated with our numbers on that problem there. Let me switch it back over. And so on number 8, again, key concepts you want to take away is you want to condense right here and then solve it out and solve your quadratic. Again, college algebra, we're not going to get nice 1s and 2s. All right, get a little long-winded here. So let's jump over and look at number 9 and 10. So number 9 and 10 are a little bit different because they already have logs on both sides. So first I'm going to condense this down. So that gives me log of x times 5 equal to log of x plus 5. And by the one-to-one property, the one-to-one property says that if you have log of x equal to log of y, that x will be equal to y. So you basically can drop those logs. And so I'm going to say x plus 5 is equal to 5x. Then we'll solve it out. So minus x. So 5 is equal to 4x and divide by 4. And so a little bit nicer there than number 8. Let's do it again with number 10. So first you're going to condense it down so it gives you ln of x times x plus 4 equal to ln of 4x. The one-to-one property works no matter your log. So even if you're working with a natural log, same is going to be true. You just set them equal. So I'm going to say x times x plus 4 equal to 4x. And solve it out. We're going to get a quadratic again. X squared plus 4x equal to 4x. I'm going to go ahead and combine some stuff together. Oh, I messed that up. This was a minus. I knew things were canceling out too much for me there. It's a minus. So I'm going to minus this 4x. Still solving quadratics from unit 1. So x squared minus 8x is equal to 0. Now this will factor in x out of both, so it gives me x minus 8 equals 0. And then I could just say, well then x is 0, and x minus 8 is equal to 0. So that would give me x to be 8. But these two answers plug into this original problem here and by our domain of x. This one here, ln x, there's no situation that we're going to get ln of 0. That won't work out. And so only x to be 8 would be the answer. So I hope this helps you with 4.4. Let me know if you have any additional questions.